These are the notes for section 7.1, proportions. We're going to start a new unit on similar triangles. The objectives for this unit, or this section I should say, will be I will be able to write ratios and I will be able to use properties of proportions. So what does this word ratio mean? A ratio is a comparison between two numbers. The ratio of A to B can be expressed A colon B, or as a fraction, A divided by B, where B is not 0. B can't be 0 because remember we can never divide anything by 0. Ratios should always be expressed in simplest form, or meaning that we reduce them. So if we have something like 2 over 4, it should be reduced to 1 over 2 or simplified. We also have proportions. So that was another word that was in our objectives, properties of proportions. A proportion is an equation stating that two ratios are equal. So there we have two equal ratios, and something that's not terribly important are the extremes and the means. A and D, which are right here, are the extremes, and B and C are the means. The only reason why extremes and means are important, or at least for the sake of this unit, are because we have these properties of ratios where we can switch the means, the interchanging of means. So if you take a look here, B and C are moved around, and we can also change the extremes. So D and A and D are moved around. The ones that are more important are the reciprocal property and the cross product property. You should remember the cross product property. That's where we just say we multiply. So that's where I get AD from. And whenever I multiply B and C, that's where we get BC from. The reciprocal property is just where we flip them. Remember, a reciprocal is a flipped fraction. Let's take a look at a couple of examples with proportions. So we're told to solve the following. The total number of students who participate in sports programs at Central High School is 520. The total number of students in the school is 1,850. Find the athlete to student ratio. So I always like to write proportions as fractions. So we need athletes over students. So the athletes, it says that there are 520. And students, we have 1,850. So if I'm going to reduce this fraction or put it in simplest form, it's always easy to use alpha y equals enter. 520 over 1850. This gets us our simplest form of 52 over 185. So that's the ratio. Again, you just put it in your calculator. We can also do the same thing with number 2. You should try this on your own. Remember, we're finding the ratio of school days to total days in a year. So there's that 2. So school days goes on top of total days. And you should be able to finish that problem. If we look at the back of our notes, we are told to reduce each ratio. This is all calculator work, but you have to make sure that you have the same units. So the units must be the same. So for letter A, I have inches and inches. So I just hit alpha y equals enter, 13 over 39, and I get 1 to 3. So for B, we also have the same units, so you can try that one out. For C, though, we see that we have centimeters and meters. So we have to convert meters to centimeters. Would probably be the easiest way. So if we have 2 meters, you should know that 1 meter has 100 centimeters. So this is equal to 25 centimeters over 2 times 100, which is 200 divided by 1. So 200 centimeters. So now I have the common units. I can hit alpha y equals enter, 25 over 200. And that's 1 to 8. I want you to try D. There are 3 feet in 1 yard. So you're going to need to convert that. And lastly, I'll do E. So I have ounces and pounds. I'm going to take 2 pounds and convert it. So I have 2 pounds, and 1 pound has 16 ounces. So the pounds will go away, and I have 2 times 16, which is 32. So I have 60 ounces over 32 ounces. Alpha y equals enter. 60 over 32 gets me 15 over 8. So what I want you to do is try B and D. So for number 4, I'm going to erase this in red to give me some more room. For number 4, I'm told to solve each proportion. So what I need to do is figure out what my variable is. To do this, I'm going to use my cross product property. Again, I said that was very important. You'll be using this throughout the rest of high school math quite a bit, and you should have used it in Algebra 1 a lot. Whenever we have the equal sign in front of 2 fractions, I could just cross multiply it. So I get 6y is equal to 9 times 18.2, which is 163.8. To get y alone, I have to divide it. So I get y is equal to, so we take that and divide it by 6, 27.3. That should be enough information for you to try letter B, and we'll do letter C together. Again, we have that equal sign in the middle, so we're going to cross multiply. We get 2 times 7n minus 1. That's going to be the distributive property. So I'm going to get 14n minus 2 is equal to 8 times 15.5. Whenever I plug that into the calculator, I get 124. To finish it, I add 2 to each side and divide by 14. So again, we can use this alpha y equals enter, 126 over 14, and we get our answer of 9. So n is equal to 9. Let's move on to a couple more examples. Here are some word problems. It says a boxcar on a train has a length of 40 feet and a width of 9 feet. A scale model is made with a length of 16 inches. So we're told to find the width of the model. We're given our proportions right here. So the boxcar's length in feet so that's what we're going to put there. We're going to have 40. That was the boxcar's length in feet over the length in inches. So 16 inches. So I need to label that feet. That's going to be equal to the boxcar's width in feet. So that was 9 feet. And I need the width of the model. The model's width, well, that's what I'm looking for. That's defined. So that's x inches. So we can cross multiply this. A lot of you might be uneasy because we have feet and inches, but I'm multiplying feet times inches and feet times inches, so the units are good. Here's what's going to happen. I'm going to get, when I cross the 40 and the x, I get 40x feet inches. And on the other side, 9 times 16 is 144. I get 144 feet inches. So when I divide by 40 feet inches, the feet inches just go away. The reason why they went away is because I have the inches right here. X will be a length in inches. So I do 144 divided by 40, and I get 3.6 inches. So X is equal to 3.6 inches. Sorry I ran out of room there. I want you to try 6 on your own. And I also want you to try 8 on your own. To do 8, it's very similar to number 7. Number 7 says the ratio of the measures of the 3 angles of a triangle is 6 to 9 to 10. Find the measure of each angle. So what you need to remember is that all 3 angles add up to 180. So here's that word angles. That's very important. So I have 6x plus 9x plus 10x equals 180. So what I'm saying is I'm taking some number, multiplying it by 6. That's where that 6 part's coming from. The 9 and the 10 also come from that same thing. So I combine like terms. I add them up. I get 25x is equal to 180. I divide by 25. So x is equal to 7.2. But I wasn't asked to solve for x. I'm asked to find the measure of each angle. So my angles are 6x, 9x, and 10x. So I'm going to do a little shortcut on the calculator. Since I'm going to be using 7.2, I want to store that. So this STO button is right above the on button. I'm going to store it as X. So I got X from this button right here, kind of close to the second. So I just hit it once. So now what I'm going to do is I'm going to type in 6x, 9x, and 10x. So those are going to be my 3 angles. So 6x is equal to 43.2 degrees. 9x was 64.8 degrees. and 10x was 72 degrees. Those are the three angle measures that I was looking for number 7. Lastly, let's do number 9 together. It says the ratios of the measures of the three sides of a triangle is 3 to 4 to 5, and its perimeter is 72 inches. Find the length of each side. So what we're given, we're not given the angle, so we're not going to set equal to 180. We're given the perimeter and the sides. So I'm going to have 3x plus 4x plus 5x is equal to 72. Again, I just combine like terms. I get 12x is equal to 72. And when you divide it by 12, you get x is equal to 6. So once again, I'm asked to find the length of each side. So the sides are 3x, 4x, and 5x. I'm going to use that same trick that I used before with the storage function, where I'm just going to do 6 store, remember above the on button, x, pretty close to the upper left-hand corner. So I'm going to type 3x, 4x, and 5x. And that gives me my lengths of 18, 24, and 30. I hope that most of this was review because you've seen all of it in Algebra 1. But if you have any questions, please come prepared and we'll do some practice in class.